Hello, guys. Okay, hi, guys. Let me introduce Ihor. He's our guest on this session, and I'm very glad to help to organize this session. And Ihor is lab director at Huawei Technologies. And while all of us are connecting and joining this call, Ihor, hi to you.
Hi.
So we have about 1 or 2 minutes before your speech will be started, and we will record all this demonstration, and later you will find it at EngX Z-Day website. And meanwhile, we can chat a bit, waiting for people. So I see you have a lot of experience in building software, in writing books, conferences. So what was your decision? Why did you go in this way instead of pure software development?
I think it is pure software development. I think that any software developer, and I said it many times in many places, that any software developer has to be, to some extent, a public person. Well, I'm talking mostly about senior developers when you have something to say to the community. But even for junior developers, without being visible, without being integrated into communities through some publicity, through let's be honest, the Twitter account, a Telegram channel, or something like that, then you basically do yourself a bad favor. You know, in one of the interviews I was giving a few actually years ago, the interviewer asked me the question, what do you regret about? What's your biggest regret in life, or one of the biggest regrets? And I said that I regret that I didn't start blogging 20 years ago when I was much younger. I didn't have as much knowledge as I have now about software development, but still I had access at that time to internet. I knew how to make websites. I knew how to write a blog, how to write papers, how to write articles and publish them online. But I wasn't doing that for many reasons. Well, there are many reasons. At that time I was shy. I thought it was not beneficial to my career, many things. And I regret that a lot. So if some of our viewers right now are junior developers or middle level developers or even senior developers, consider starting your blogging activity, your public activity right now. Don't wait, because
Okay.
later you will regret.
Okay. So will you tell us today about how to start the blogging career, or the topic will be different?
Uh, yeah, that's a good question. I actually wrote a book about that a few years ago, which is called 256 Blog Hacks. You can find it on my blog and on Amazon. So in the book, I explained how to start, and more important, I explained why to start. And I said there that if you don't have anything to say, if all you can say is just confirm what was said before by other people, then you better not start blogging. So you need to find something, some area, some niche, some territory, some subject where you disagree with other people, where
Mhm.
you are a minority, where your point of view is not the dominating one. And there you start writing something. And how you will start writing and where you will publish your stuff, that doesn't really matter. I mean, I gave many examples in the book that you can go on Twitter, you can make your own blog, you can publish books, now there are many channels, and all of these channels are accessible. It's not like 20 years ago. So now you can go to TikTok. I mean, it doesn't matter where you go. What matters is that you say something that is not the same as other people are saying. In that case, you will get your audience. And it's not really important to be right. It's not very important to be 100% right. What's important is to be confident about what you're saying. I mean, I'm wrong about many things, and our viewers who are watching us right now, they can confirm that. So I'm wrong sometimes, and very boldly wrong, and I make mistakes. But the more I'm trying to be confident about what I'm saying, and that helps me to attract readers who sometimes agree with me, sometimes don't, but they come and they read. I mean, they stay with me. They listen to what I'm saying.
Yeah, and you share your thoughts finally, so people can receive feedback on the thoughts.
That's right. Yeah.
Yeah, I look forward to your presentation. Let's
Okay.
start it. And we have a live Q&A session in our chat. So guys, if you have any question, just write them down, and after the presentation, we will answer to them. Oh, actually, Ihor will answer, and I will help to find the most interesting. And good luck.
All right, let's go. So I will tell you, well, I was thinking for quite a while how to name this presentation, so I decided to call it line number 0. This is something which each project has to start with, and they don't, so that's why they fail. So let's go step by step, and I will give you some practical advice about how to do it. So first slide is about my background. So I am coming from Huawei. So I work in Huawei for the last 2 years. I'm a head of a small research and development lab. We create tools for developers. So we make instruments which help other programmers to write better code, like static analyzers. We even make a experimental programming language. We make automated refactoring tools. So many things which are for other developers. For example, just giving you 2 examples so you know what we're busy with. For example, polystat.org, that's the static analyzer, artipy.com, it's the binary artifact manager. These are 2 open source projects which we work with. We have about 30 people in the house, I mean in the laboratory, and we have about 40 people external. And that's what gonna be. That's what my presentation will be about working with the people who are external and actually observing their mistakes. And I will try to suggest a method to correcting these mistakes. But now you see the picture. So the lab inside is even smaller than the outside teams which work with us. So we run right now 9 projects. 9 projects are going forward right now, software development projects. And I do both. So I do coding in a few of these projects. I write code. You can check my GitHub account. You will see, the code I write every day. And I do management. So I observe the situation in these 9 projects, and every week I talk to people who are there, to architects and developers, and we together decide what's wrong, what's right. So final line, if you want to join any of these projects, by the way, if you want to be there, they're all open source. So if you want to, it's a small portion of advertisement now. So if you want to join any of these projects, then find me on Telegram and we can talk. And we're looking for open source, first of all, programmers, and we are actually paying them. So what's going on usually? How things start, how they follow, how we see problems in the project. So usually it works like this. First, when we start a new project with an external team, they tell us, what do you want us to create? So imagine there's 5 programmers somewhere in another city. We contract them, we ask them, we sign a contract, we have some budget, some time. Okay, they come to us, technical meeting, they say, okay, what do you want us to create? And we tell them that this is the scope, this is the technical scope. And they say, okay, cool, let us write some code and let us think how to do it right. So they just go back to their offices. We don't know what's going on there. They start writing, they start coding, they start thinking. And at some point of time, they continue coding. When we call them, when we have meetings with them, and we try to do status meetings every week. So we're quite aggressive in the area of status control and control in general. Me personally, at least. So when we ask them what's going on, like show us some, tangible results, give us the product, they say it's a complex case. We need to code more. We need to, it's not just making a small iPhone app. We're actually doing complex projects. So they usually refer to this situation as a complex case, and that's the number one excuse for not finishing, for not giving us something which we can, touch and which we can play with. So 6 months later, things are well enough. I mean, they tell us what they do, they explain how things work, but 6 months later, they say, okay, now we have something to demo actually. So now we are ready to show you the ready product. So the product which we can give to you, and you can play with this, and everything will be fine. And we're saying, we just look at the product and we say, okay, what is this? I mean, this is not exactly what we expected. This is something, when we actually touch the product, when we get the product in our hands, we open, we try to run it, we try to, to play with it a little bit, and we understand that this is something completely different, or a lot different, maybe not completely different, but still a lot, many things are different, not how we expected. And they say, okay, they get offended. They say, okay, maybe you should hire another team because we clearly don't understand each other. So it gets personal. I mean, they get offended because they invested so much time into this. They spent 6 months on working on that. They actually tried to do the best. And in the end, we are not happy and they are not happy. And we say, okay, hold on. Maybe we can save this. We can still get something out of it. So show us the code. I mean, open the code. Let us look at what's inside there. Let's do some investigation. Maybe we can improve it because functionality wise, it's not exactly what we're looking for. So how about we change the code? And then when we look at the code, we say, okay, oops, the code is a mess too. I mean, it's also a problem there. So the code is something which only these guys can know how to work with. And the product is something which these guys believe it should be done. So you probably understand that this is not really agile way. This is not very iterative development, incremental. So people were just waiting for too long and delivered the result too late. And even though the books are saying that this is not how things should be done, in all situations, in all projects, which we do right now in 2021, Agile was born, I don't know how many years ago, 20 years ago. So in 2021, all software teams which I meet today, these days, they all do the same. That's a very traditional flow of events, usual flow of events. Nothing changes. They think that they need to work for 6 months, create the product, and deliver the product, and then get it, celebrate the success. And the success is not being celebrated by the end. So they say bye bye. We say bye bye. It's a lost partnership. It happens. So how I would see the flow of events differently, what I would love to see instead, I would love to see it this way. The first, we sit together in the beginning and they say, okay, what do you want us to create? They ask this question. And we explain what they want to create. And then 1 week later, they come to us and say, here's what we've done, check it. 1 week. They deliver something to us. They show us the product in 1 week. It's small, it's broken, it's not doing what it has to do, it's not complete, absolutely not. It maybe is even written on the wrong programming language, but it's a product. So we have it in 1 week. It's delivered to us and they say, okay, check it, what do you think? That's what we've done. We've been coding for 5 days. We assembled something which looks like a product. Take a look. We take a look and say, look, cool, but this is not what we meant. I mean, we meant something different. That's going to be the reaction, which is in 99% cases will definitely happen. But that's okay because it's just 1 week. And then they say, okay, no worries, we'll redo it. They will answer this. Because for them, it's really not a problem. It's just 1 week of time wasted. It's not half a year wasted. In this case, there will be no offense. There will be no disappointment. There will be only just pretty normal, routine work situation. Okay, you don't like it? Let me work another 5 days. Let us work another 5 days. So we do it differently, we improve it, and you like it more. So they go back, they redo it, and they come to us again, and we will be able to say, let us review the code too. So not only the product, but let us touch the code which you write. Let us open the repository. Let's see how you design your code, how you organized your code, how you configured your build, your unit tests, how you structured your architecture, how you put the classes together. Do you have UML diagrams and all that stuff? So we open up. So it's an open product for us, not a tangible something, but actually open one. And they say, no problem, it's in GitHub, it's in Maven Central already. So it's released, it's already published, it's open source, because most of our projects, actually all our projects we do open source. So their answer has to be, look, it's open source, it's already there. We already packaged it, we already released it. It's in case it's in the Java package, then it's in Maven Central. So everything is like done by the end of the week. So it was just 1 week time, but everything is like complete. It's like micro project is completed, like 1 week long. Micro project is completed and they have it demonstrated to us. And in the end, we say, no problem, that's great, come back to us next week, love you. So that's the proper flow of, that's the end of the line. Yeah. So that's the proper flow of events, how it should happen. And it should happen every week. So that's the discussion, that's the conversation I would love to have every week, but I don't. It doesn't happen. Why it doesn't happen? Hard to say. I don't really have an answer for that. I mean, I have a number of answers, which I will give you right now. But the bottom line is that people are not doing incremental development at all. They read books about that. They listen to agile trainers, coaches, whatever, and they still do incremental development. Why it happens? So why developers? That's the title. That's the title line, the headline. Why developers don't release first? So what happens? Like, I mean, the symptoms are they start coding, they code for half a year, and in half a year they release. So their first release happens in half a year, not in 1 week. That's the symptom. So if you have the same symptom in your team, then you have to then you should listen to the rest of the presentation. The symptom as is your release, your software is released in 6 months instead of 1 week. Remember this timeline. So why it happens? I identified for myself a number of potential reasons why people do it. Reason number one, I think it's coding is fun. So when somebody comes to you and says, here's the budget, here's time, like 1 year or 2 years, and it's an interesting problem to solve, then you inevitably, naturally will just sit down and start coding, and you don't want anybody to bother you with saying this is not the right way you code. You just have fun, you just enjoy coding, and you don't want to deal with these business presentations, releasing, packaging. You just code, and people love to code. I mean, ask professional programmers, ask junior programmers as well. They're quite these people, including myself, we would love to code with no deadline, with no end, with no finish line. We would just love to code. And every release, it's a finish line. So every time you go to the team and say, okay, stop it. It's time to package everything. It's time to call it version 0.7, 0.3. And it's time to put it to production. So they need to stop coding. They need to see how it's ready or not. So it's sort of a milestone. It's sort of a deadline. And people, prefer not to do that, and prefer not to think even about packaging. That's close to the maybe a few next topics. So that was first reason. Coding is fun, and I think it's quite common in software team. Actually, I will show you a number of reasons, and every second reason I show is stronger in my mind, stronger than the previous one. So coding is fun is the easiest to fight with. It's just say, okay, guys, you had fun for a week. Now it's time to do something else, and they can stop basically. But second one is arrogance and self-confidence. Arrogance means that I am the smartest, and I know what I'm doing. So self-confidence, I understand the requirements. I know how to solve the problem because I'm a senior developer. So I don't need any customer or even a technical guy from the customer side to tell me how to write code. No way. I am sure that I'm doing the right thing. So don't stop me. Don't let anybody see my code. Don't let anybody tell me how to organize unit tests or how to design my classes. I know what I'm doing. So I've never seen a software team which would say, we are not sure that we're doing it right. They're always sure. They're never saying to the customer that, I'm not sure, so you better help us. You better take a look at how we do it. So how about you take a look at our the way we design these Java classes, and maybe ask your guys to do the independent review of our code. I mean, people for example, from our side. So the contractor come to us and say, we're not sure, take a look at the code. Never happens. This is self-confidence in a bad way. I mean, self-confidence probably in a good way, it's good. But when you are self-confident as much as it being arrogant in a way that you believe that you know everything, and there is no room for improvement, then that's it. So people are only when it's absolutely necessary by the business, when the contract says, okay, it's a timeline you need to deliver, at that point of time they say, okay, now take a look at our product. Okay, because they cannot say otherwise. But until then, they're trying to always, fly away from this necessity to be checked, to be controlled. Number three is Perfectionism. When you code for a week, imagine how good is going to be your code. It's going to be bad, right? It's going to be low quality. It's going to be something like a uh, piece of uh, piece of Java lines. Let's call it this way. So it's going to be just a collection of files. Everything is done wrong, or almost everything is done wrong. So you don't want to call it a product. I mean, you're trying to do better, and we all programmers are like this. So we're trying to make a product better. So what's the point of releasing the product in 1 week when it's completely wrong? I mean, it's completely broken. It's not even a product. It cannot do anything. It's just a collection of a few files, and we're not even sure that the product is doing something. What's the point of packaging this and releasing to Maven Central, for example? That's what programmers think. So there's absolutely no point in doing that. That's called perfectionism, and it's wrong. We shouldn't think like this. We should understand that software will never be perfect. It's not going to be perfect in a week. It's not going to be perfect in a year. It's not going to be perfect in 10 years. So we always make it better and better and better on each increment. So perfectionism is only killing us here if we're trying to be perfect. And people do try to be perfect by not releasing products early, by releasing products later, and that kills projects. Number 4 is fear. That's pretty obvious reason that people, when we do contracts, so programmers, they are scared of being exposed to criticism, to external review. So if I'm a customer and they show me something in a week, and then week after, and then week after, and 3 weeks through, I will see bad code, bad product, not enough functionality, not enough testing, whatever, not enough, then maybe in a few weeks I will say, how about we stop this contract? Because we see where it's going. I mean, we see that you guys don't know what you're doing. That may happen if the customer is, uh, let's say, stupid. I mean, I don't like this word, but okay, less competent that the customer has to be. So if the customer is incompetent, if the customer doesn't understand this incremental delivery concept, philosophy, then the customer will say, yeah, I was working with another team before, and they were delivering me the product 3 times through the course of a contract of a year. So they gave me something in 3 months, they gave me something, and then another in 3 months, and maybe they gave me everything in the end. I don't know. But that clean and shiny presentations, demos, that's what usually software developers do in order to impress the customer. But only an incompetent customer can be impressed by that. A professional customer who knows how to manage software project, a professional customer will require incremental frequent releases once a week. Every week a new product, every week a new version, completely packaged, completely. We will discuss a bit later what I mean by a complete product. So if you meet the customer which is incompetent, which expects you to bring everything, shiny and everything great, then yes, probably your fear is right. So in this case, don't try to deliver incrementally. But in my case, I'm also a programmer. I understand how to write, how to code on my side. So I expect them to not be afraid of me, but they are. They are scared. I feel that this is one of the reasons why people don't deliver incrementally. Number 5 is one of the most dangerous reasons why they don't do this. It's beliefs. So some people believe that they shouldn't deliver incrementally, and that's the hard case for me. So sometimes I tell them that, look, guys, how about you start delivering, because we're like 3 months already in the project, and we haven't seen a packaged product as of so far. 3 months, not 1 week. So you give me something. I mean, package it, call it version number 1, but give it to me. And they say, you know what? This is how you think software has to be developed. But we have our own perspective on that. We believe that complex, professional software with a lot of features has to be delivered differently. It has to be properly designed first for many months, then properly coded, properly implemented, and then delivered maybe in 6 months, maybe in a year. So that's how really professional software is being developed. So they say your agile incremental development ideas, they are for small iPhone applications or whatever, like pet projects. But for really research and development, fundamentally difficult, what have you, software products, you do it differently. You do, but they don't say waterfall because waterfall is a curse word right now. So you don't say it in a software team, but they say more professional. So they position agile, incremental development versus professional development. So you guys want incremental and agile, yeah, because you're kids. But we want professional because we know what we're doing. So we're way more mature than your incremental whatever. We don't need this incremental. We don't need every week. What's the point? We know what we're doing. That's we're getting back to self-confidence and arrogance, but that kind of goes together, I think. So the beliefs, and it's difficult to change that no matter how many books you give to these people. They know what they're doing better and they believe in professional in quotes, which is waterfall by definition. And final, no experience. That's probably number one. That's probably number one reason. They just don't know how to package and deliver every week. They just don't have an experience. So they can say that they know how to do it. They can proclaim that they are incremental developers. They can call themselves iterative adepts of iterative development. Doesn't matter. They just don't know how to do it. They've never done this. All they know is how to start the IntelliJ idea, create some Java files, then click run in the IntelliJ idea. It runs and they are happy about it and they continue coding. They click run, it runs, they code. And at some point of time I come and say, did you manage to automate the build for a different production, for a different test platform? And they're like, what? Like, huh? Automate the build for different platforms? What exactly do you mean? They don't even, some of them don't know what is Gradle or Maven. I'm talking about Java. They heard those names, but they don't know exactly what they're for. They have IntelliJ IDEA, which is a powerful tool, which kind of make programmers stupid. I mean, in a good way. I mean, or in a bad way. I don't know. But if you stay in the IDE all the time and never get back to command line and never do this automation, which we're going to discuss in the next slide, then you sort of degrade yourself to a coder from a designer, from a software designer. So no experience. That's the reason, probably number one. They just don't know how to do it. And I will try to tell you how. This is going to be my last slide, the most important. So let's discuss how we can automate that. So what exactly I'm expecting every week from a software project to call this project really incrementally delivered. Not waterfall, but incrementally delivered. So a few things. Thing number one, you start a project, 1 week is gone, you have to have a README file. I mean, I'm talking about GitHub development. I don't know who is developing Node in GitHub or GitLab right now. So I hope everybody is staying there. So let's say it's a GitHub README file. In the README file, you explain what you're doing. You explain the requirements to your product. You explain the functionality of your product. You explain how I, as a user, can install this product and use. You explain how I, as a developer, can contribute to your product. You do it at the first day of your product, not start the IDE and start making Java classes, but you make the README file. And this README file is updated every week. So when you, at the week number 13, come to me, who's your customer, you always make sure that your README file is up to date. So it explains, just like I said, your requirements, your functionality, how to use them. I mean, what is in the product, how it works, and then how to use it, and then how to contribute to it. These are the things which have to be there. Most people don't do. Thing number one, you have to automate your build. I mean, maybe for somebody it sounds like just fancy words, but build automation means that I can take your product, take your source code from GitHub, do git clone, and then I just type one line, one command in command line, and I click enter, and your product is built. Built means one, depends on your programming language. Let's say it's Java. So in Java, it means all the Java sources are compiled, and then all of them get together, including unit tests. Then all unit tests are executed. Then some extra checks are being run, for example, static analysis, and then code coverage is controlled. So that's a long script, which is now automated by special tools like Gradle, for example, for Java World, or Maven for Java World, or for other languages. There are different tools. But the bottom line is that I have to be able in the command line just to say one command, and everything is built. It takes some time, maybe a few minutes, maybe I don't know, a few hours, but it runs, and in the end it says build successful. So if you don't have that, you don't have a product. And that has to appear on the first week of the product. You don't wait for that for 2 months or 3 months. You start with that. If you don't have your build automated, then you don't have a product. You have just a collection of source code files, which only you know how to put together. Only you know how they work. So if you quit the project tomorrow, the project is gone. We lose everything. So build automation is extremely important, and it has to be automated in just one line. It's difficult for most people, just like I said on the previous slide. For most people, they don't have experience how to do it. It's hard. So do it. Do it first, and on top of that, you build everything else. Next line, next thing which you have to have is strict style checking. So again, people believe that they are so smart. They write extremely nice Java, C, Python, Ruby codes because they write it for 10 years. No, you guys don't write nice code. You write the code the way you write code. But style checking checkers are the tools which make sure that your code is unified. Make sure that the way you write code in this file and the way your friend writes code in another file, they look exactly the same or very close. In order to assure that these two files, they look close to each other, there are style checkers. And you introduce style checkers at the first week of your project. You don't wait until the code is written, like many people say. They say, we write the full code, we have something to check, they say. What's the point of do style checking now if we have just 5 files of code? It's no point. We write all the files, we're gonna have like 100 files, and then we do style checking. You will never do style checking in this case, because it will be too late. And the cost of introducing style checking will be extremely high, just like for the unit test, exactly the same. So you start with style checking. You start with adding checkers and control mechanisms into the build, which will control your entire development. In one of my videos, I said recently, again on the same subject, I said that style checkers and automated build and unit test, all these instruments are your teachers. So they teach you how to write better code because they control you. It's like they're like your mentors. So you write bad code, they push you. I mean, they punish you for that. You write bad code, the build will crash because style checker will say, look, your code is formatted wrongly, and you have to reformat the code. So if you do it from the first day of the project, then during the course of the project, the style checker will punish you multiple times and you will learn. So what's the point of introducing a mentor when the project is over? It's not going to teach you anything. But I think most people think that there's no way, no room for teaching for them. I mean, they know everything already. So what kind of mentor? I'm a programmer with 15 years experience. If you are a programmer with a lot of years of experience and you don't use style checkers, then you are a junior programmer who is just old. That's it. So senior programmer doesn't mean that the guy is old. It means the guy writes clean code. And I've seen many people who are old and junior at the same time. So don't be like that. So style checker is the first step you do. I mean, it's something which stays inside your build. Number 4 is CI badge. The CI badges. Well, we now use GitHub Actions, which automate continuous integration. It's a very convenient tool on GitHub, and they have these badges. So if your repository with your code doesn't have the CI badge, that's a complete mistake. But some people and many people, they just put this badge and the CI stays in the red situation, in the red status. So meaning that it's impossible to build anything. I mean, the errors are there and something is wrong. And they're happy with this. They just don't pay attention to the CI badge. Like whatever, it's like a badge. We do real coding. We do real work. This is not what we care about. We care about writing code. We don't care about some badge. No, the color of this badge is the indicator of the health of your team. So if you have this badge turning red frequently, it's a symptom of a low quality of your team. Senior programmers, when they develop the code, they have this badge green always. That's the indicator of seniority of yours. Not the way you solve algorithmic problems, but the way you organize your work, the way you use instruments. So CI is the instrument. If the badge is red, it means that if we stop the project right now, we're going to get a broken code in our hands. And if you allow that to happen, then it's just bad. So make sure you have the CI badge in the first day of the project, and make sure it stays green all the time. If it's red, fix it as soon as possible. But think why it's red, because it shouldn't become red. I mean, you have to configure all other instruments to prevent this from happening. And we can discuss that separately. It's a separate topic, how to make sure that the badge doesn't go red ever. Uh, Two more lines and I'm done. So the line number 5, you need to know your test coverage. Again, very interesting thing to know, how properly covered your tests are. Most people say that we're going to test it when we have code, when we have tests. Like, what's the point of checking test coverage now if it's so low? It is a point. You have to check it no matter how low or high it is. It's 0%, it's 1%. Show it to us. So you need to configure test code coverage inside your build. And the final, two more lines, the line which is about latest binary. So you need to make sure that the latest binary of your code is packaged, is built together, is assembled together, and deployed to the platform where it has to be deployed. So you deploy it on the first week of your project, the same way as you're going to deploy it on the last week of your project. It's exactly deployment mechanism, which will stay with you during the course of the project. So you're going to, if the project is going to take 50 weeks, then you're going to deploy 50 times during the course of the project. 50 releases you're going to have. Not 5 releases in the end of the project when everything is ready, like most people think, but you're going to do it 50 times. The same routine, the same script, the same mechanism will do it. So show it to me on the first week. If you don't show, then it's bad. And finally, deliver to the customer, just like we discussed. So when it's done, deliver to the customer every week. Let the customer touch the binaries and the code openly. But in order to do that, in order to have this, to not have the fear, to not have the bad feeling about the customer touching something which you don't love, see the previous items I mentioned. The build is automated, style checkers are there, continuous integration is complete, test coverage is checked, so meaning that you have tests. That will guarantee you that your customer will not blame you for being unattentive to your code and for negligence or whatever. So that's it. That's what I wanted to say. Thanks for listening. Hopefully I gave you something new so you can use it in your coding daily and daily.
Hey, Igor, thank you for your presentation. It was really interesting to see your thoughts, and I totally agree with you that some events should be established on the project from the very beginning. I like that idea about frequent and iterative releases, but people ask, and I also have the same question, how we can prove the customer that iterative delivery, incremental releases are better than expecting in three months or 6 months. So what we can tell them, maybe you have some magic words from your experience, how to teach, what advantage to show customer?
Yeah, that's a good question, actually. I think that teaching is not going to help, and explaining is not going to help, and convincing them is not going to help. I would just do it this way and just initially ignore the complaints they may have. So some customers may say, I don't want to see it every week. Like, what's the point? You're showing us the broken product over and over again. Like, well, you're like doing it for like 10 times already, and every time the product is lacking features. So you're just annoying us. I would just ignore that and keep doing it. So keep doing it. You have to be in charge of the project, not the customer. That's my recommendation in general to project managers. So customer is just one stakeholder of the project. It's basically a money provider. It's a sponsor. It's a source of resources. But it's not the lead of the project. It's not the project manager. So the project manager is the person who leads the project, who is responsible for success or failure. Customer is just yet another, resource provider, just like programmer. Programmer provides resources in terms of coding time. So I'm a programmer. I write code 8 hours a day. That's my resource. Customer provides money, provides computers, provides whatever. We're more or less equal stakeholders. I mean, on the line of on the board of stakeholders, we're equal participants. So don't listen to the customer. Don't let customer to tell you how you organize the development. You organize the development. And customer, if it happens that the customer will stop your project and cancel the funding, and so be it. I mean, that happens. But it's better. The situation is better comparing to the situation when you will follow the process enforced to you by the stupid customer. That will be worse for you, for your career, for the project, for everything.
Yeah, thank you for the answer. So we can say the customer and that we own the delivery of project, and therefore we know better how to do it.
Right? Exactly.
One more question about test-driven development. Is it a prerequisite to release often, release incrementally? What do you think about it?
I don't think that test-driven development. Uh, well, test-driven development. It's a uh, it's a very long, it's a very big subject. But to answer it shortly, I think that development must be supported by tests. I don't really share the idea of driven development where the tests they drive the development. So we listen to the tests always. It's kind of it's hard to imagine how to do it in real production. I tried many times. It just doesn't work. So what works is that when you have tests, when you try to make as many tests as possible, to cover your code as much as possible with tests. So you have to be driven by, I would say, test coverage driven development. That's more accurate definition of the process I would give to myself. Test coverage. So you look at your coverage, you look at how much you cover your code with the test. And if the coverage is low, then this is what drives you forward. This is what tells you, come on, something is wrong. So we need to get better coverage because we have troubles in production. Troubles in production, they happen. Why? Because the coverage is low. Because we forgot to cover this functionality, we forgot to cover that functionality. And that's why we have bugs and bugs and bugs from production. And instead of fixing bugs and just releasing new products, and that's it, you look at the bug, you increase the coverage in this place where the bug happened. So you patch your coverage. So imagine you have this like a blanket with the pieces with the holes there, and the customer like poke you in these holes and say, there's the bug, there's the bug. So you patch your blanket with the unit tests, with the integration tests. So that's what you have to be driven for. But if you don't have these bugs, if you don't have the holes, if you don't know where they are, just coding because your tests are telling you this, I don't really see it happening in real life.
Yeah, and probably related question. So do you like the idea when CI has a rule which does not allow to decrease code coverage? Some quality gate.
No decreasing of the code coverage. Yeah, I know. Like we have this plugin, even we have the plugin in GitHub, which is checking the pull requests, and when the pull request decreases the coverage, and it raises the concern. I think it's a good idea. Yes, I would actually embed this, and we do it in a number of projects. Embed this control into the build, the automated build. So the build has to check your code, run all the tests, and the build has to be a hard-coded number of the minimum allowed code coverage. Let's say 80%. So if your code gets below 80%, then the build gets red. So the build is not successful. It's a good practice. It's a good practice, but it's only for really strong teams. I mean, the teams which are not strong in a way that strong by the technical skills, but strong in the management skills, in the soft skills. Because if your team is weak, and by weak I mean the team which is unorganized, undisciplined, not controlled by the manager, just a group of people doing coding because it's fun. This is weak team. So in this team, when somebody introduces a code which lowers the coverage of the code, that guy will easily get that code into master branch anyway, because the team is weak, because the team will not be able to say, no, we're not going to get your code no matter what you think. And even worse, we're not going to even pay you for this work because you just did something which is not good enough for our quality control, because you lowered the coverage, and we're not going to pay you for this day of work. So do it better, and then we're going to pay you and deliver to us. How many teams are strong like that? Most teams will be like, okay, sure, well, you did it this way, but please don't do it next time. But this time, okay, we will accept it. We understand it, blah, blah, blah. So we just lower the barrier. We'll lower the threshold. Okay, it was 80. You gave us some code. Now it's 75. We forgive you. So if the team forgives that mistakes and doesn't punish for such mistakes, then the team is weak, and then there is no point of doing coverage control.
Yeah, since it's very interesting about weak teams and their way to handle these quality gates. And I have one more question related to this topic. What can be done from the individual backend developer side to improve the development cycle, mobile application of the whole product? Because a lot of these techniques require some DevOps skills.
Yeah, well, I think that this, I don't really like, to be honest, I don't really like the separation between programming skills and DevOps skills. And I see it many times. Very often when I ask people to do this automation, to configure the project properly, very often programmers say, I'm not a DevOps engineer. I know how to code. I don't want to automate the build. I don't know how to release the binary to the customer. Come on, it's not my job. I'm not a script writer. I don't know how to write all these scripts in Bash. We'll just package something, put it. I mean, come on, hire somebody else. I'm a programmer. I'm IntelliJ ID. I know how algorithms work. That's just nonsense, if you ask me. I don't believe this is. It's like, I'm a programmer. I don't know how to install Windows or install operating system on my computer. So I call a guy. He does everything for me, and then I can work. It's something similar to this. I mean, you don't do this. You know how to do this. That's part of the job. These are your instruments. So how good is a plumber who doesn't know how to fix the instruments? How good is a carpenter who doesn't know how to fix the instruments and how to make instruments good? This is your instruments. You need to configure that yourself because this is what you work with. This is like your hands. You cannot let somebody else do this and then blame them. Okay, the build is broken. I don't know how to fix it. We call somebody. No. So it has to be your job. You're a Java developer, know how to deliver your code, know how to automate everything in the Java world. You move to another world. Actually, I can say that I am a developer in Java, Ruby, C++, JavaScript, a little bit of Python. So every time I move to a different language, I start from this. And I spend sometimes weeks, sometimes months to understand, not months, weeks, to understand how in the new language this stuff works. This is the first thing I learn before I even learn how to write code in the language. I learn how to automate everything. So this is the first skill. It's a line of code number 0. That's what you start with. This is not the tail of the job, it's a head of everything. So back-end development, front-end development, doesn't matter. Just your language, the language you work with, learn how to automate everything and be the DevOps guy for your project.
Yeah, thank you. So just learn your instruments, yeah, and get knowledge.
Instruments, right?
I have a couple of questions on unit tests. So the first is how to ensure the quality of unit tests. And second is how far unit tests alone can carry project on forward before introducing of the next level like integration or even end-to-end.
The question is how many unit tests we need or how far we can test. I did get the question.
Yes, how far unit tests can carry project, so, and how to ensure their quality, because it can be just a lot of logic.
Yeah, that's a huge question. I mean, that's a question a little bit outside of the scope of this discussion, but it's a perfect question. And there is no answer, I believe, in the world for this question. That's probably something for us to discover in the next 10 years or so. For us, I mean, for computer science, for programming industry. So let me answer the first part of the question. We need a lot of unit tests, and the more unit tests you have, the better. That's just a simple formula. You have a coverage of 80%. I mean, the coverage is not like a number. I mean, there are many criteria of the coverage. You can have an 80% coverage, but zero usability of these tests, because you can just, they can be just line hitters. So they cover everything, but they don't really check the functionality. So don't pay attention only to coverage. But no matter what, the more tests, the more deeply you test your code, the more deeply your tests touch your code and massage your code, we can say it this way, the better for the code. So never stop writing this. And actually, on a mature project, if it's developed right, like really mature project, like a project of 2 years old, for example, or 3 years old, the amount of unit tests by the lines of code, in my opinion, has to be 3 times larger than the amount of the code. And every time something new has to be introduced in such a mature project, it has to bring with itself a huge amount of changes in the area of unit tests and a very small amount of changes in the area of production code, the live code. That's the indicator. That's the indicator of a healthy software project. And then answer to the second question: how can we make sure that the tests are good? Guys, this is something for you to find out. Well, there are many anti-patterns in the area. Go to my blog and Google by test anti-patterns. You will see a list of like 30 different anti-patterns, which I collected from different sources, different books, different websites, just names of them, like over 30 or something. Anti-patterns, so how to make your test wrong. Even though it's going to be a test, it will work, it will test the code, it will introduce some coverage, but it's going to be a bad test, which will cause even problems in the future. So if you just, mindlessly, without thinking, introduce unit tests just because you want to have more tests, then you're preparing yourself for larger problems, that's for sure. But how can we automatically look at the tests and say, look, these tests are wrong? I don't know. And that could be a very good tool if you design such a tool for Java, for example, which will look at your test suite, like all the 500 tests which you created, and say, look, 300 of them should be removed better or improved because they're wrong. That would be a really great tool for all developers.
Yeah, let's look for it. Maybe it's already created. Probably the last question on this test topic is about gerkin tools, which allows to write specifications in human readable way. Did you use it? Do you see any future for it in collaboration with customer? What is your opinion?
I didn't use it. I think it may be an interesting tool. Maybe I have no experience of using that, but I think in general it's a good idea to integrate a natural language with a programming language in general. So Gerkin, I even made my own language a few years ago, which allows you to write a specification in the English, and then from this specification it generates you UML diagrams, it generates you maybe even the code. So it's a formal. It's called controlled natural language, CNL. Controlled natural. It's like natural language, like English, for example, but you cannot use it. You can say whatever you want in this language. You just format your thoughts in certain ways so that the computer understands you automatically. And I believe this is, in general, a future of programming. But the DSL is the same. DSL is the same topic, like domain-specific languages, which are more technical. So they're not exactly like English, but some of them are quite recognizable by humans. The DSL. So Ruby is the territory where many of these DSL languages are created. And for example, tools like Puppet and Chef, they're extensively using this kind of DSLs, which stay on top of Ruby, in order to let people explain what needs to be done without even knowing that they're writing Ruby code. So you write Ruby code, which looks like English, and then it just works because automatically compiles to binaries. So I think that's strategically the right direction.
Yeah, and the last question, we are almost out of time. It's about cost of ownership. So with these frequent releases or huge set of unit tests, integration tests, cost of ownership of your software is increasing. So maybe that does it worse, or maybe it's too much for some teams, some companies.
It's the same as saying that what's the cost of quality. So okay, how about we instead of cleaning the floor in my apartment, I will stop doing that because it takes my time. So I just stop cleaning the floor, and my life will be better because I save a few minutes, like every day or every week, and then I use this so on and so forth. So of course I will get some extra time, but the quality of life will just go down. The same here. So if you invest your time into these frequent releases, then your development will be easier every day. So you will spend less time on something else. So of course, this weekly routine this text which you see on the screen right now will take some time, will cost you something. But it will cost you on the first week. It will cost you on the second week. It will cost you 0 on the week number 13. On the week number 13, it will give you a lot. It will start paying you back. So initially you invest into this infrastructure, then it starts paying you back. And in my opinion, well, in my experience, it will pay you back way more than you invest into it. I can tell you, I have on GitHub, I have probably 100 open source projects, like 100. Maybe I'm exaggerating, maybe 80 or something, but close to 100. And all of them are in some use. So I have some users who use them. Some of them are like 300 stars, some of them like 500, 600 stars. So they have users. Imagine, and all of them are automated like this. So all of them have everything that mentioned on this page, all of them. And that makes it possible for me to spend like 1 hour every 2 weeks to manage them all. I don't spend like every day because I have something else to do. So all the projects which are old, which stay in my portfolio for like 10 years, some of them are 10 years old. I don't touch them, but I know that they have this automated, this routine automated, and people make changes. They're contributors, volunteers, they submit pull requests. I just click one button and the whole thing just runs again, just like I ran it 10 years ago. The same cycle goes again. I accept their changes, everything is being checked, tested, and the changes go in. I don't need to open that code anymore. I don't even need to remember what the code was about. This build pipeline, controls everything on behalf of me. Without this pipeline, you as developers have to control what's going on. But it's just okay for one project. But imagine you have 100 projects like me. I mean, old projects who you don't want to deal with, but you want these projects to stay alive so people use them. So automate everything. It's your instrument. It's like it's an environment which you build where your project starts to live. And you don't first make sure the project gets born and then live for half a year, and then you give the project the environment. That's just silly. It's just a upside down idea. First you build the environment, then you let the project live and grow in this environment, not the other way around.
Yeah. Thank you, Igor, for your answers and for this presentation. We will try to provide answers to questions what are not answered yet. And guys, you always can find the record of this session on communityz.com. So thank you for your visit. Thanks for sharing with us these thoughts, and look forward for the next meeting.
Thank you. Thanks for inviting me.
Yeah.
Bye-bye.